projects. In this video, we are going to explain the project implementation of blockchain in financial sector to improve scalability. Introduction. The project's primary goal is to bolster the security and scalability of the financial sector. Traditional financial systems are vulnerable to cyber attacks which can compromise data security. They rely on centralized servers, creating a single point of failure that can disrupt the entire system. Data immutability, ensuring that recorded information cannot be altered, is lacking. Transactions are traceable, making them less private. To overcome these challenges, we are integrating blockchain technology into financial operations. Blockchain is like a digital ledger that records transactions securely and transparently. In our case, it is used to store every financial transaction such as deposits, withdrawals, fund transfers, payments, etc. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. Blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And in this project, we use Ethereum, a blockchain platform famous for its creation of smart contracts. These are like digital agreements where all the terms are written in code. The code and logic of smart contracts, which enforce financial agreements, are stored on the blockchain. These contracts may include rules for account creation, interest calculations, and transaction validations. Objective of the project. So, as I mentioned before, the primary goal of the project is to boost financial security by incorporating blockchain technology into traditional banking systems. The aim is to enable decentralized data storage through blockchain's peer-to-peer network, ensuring that data is resilient and accessible across multiple network nodes. The objective is to improve the security and integrity of backend records, ensure transaction privacy, and reduce maintenance costs through blockchain's unique features. And the project's goal also includes developing a user-friendly banking application using Solidity smart contracts on the Ethereum, facilitating account management, deposits, secure transactions, and an intuitive interface through Django integration. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed few modules. The first module is Sign Up. In this module, users can securely create their accounts by providing personal information, and the system records these details on the blockchain, ensuring data integrity and user access. The second module is Login. Here, users access their accounts by providing login credentials, and the system verifies their identity for secure account access, relying on blockchain backend authentication. The third module is Deposit Amount. In this module, users can add funds to their accounts, with the system securely recording the deposit on the blockchain, allowing users to maintain balances for future transactions. The next module is Send Amount. This module enables users to send funds to other users or external accounts with blockchain verification, ensuring secure and accurate peer-to-peer transactions. The last module is View Balance. Here, users can effortlessly check their account balances, and the system retrieves this information directly from the blockchain, allowing users to monitor their financial activity with confidence. Blockchain integration. Blockchain technology is employed to store data securely and in a decentralized manner. Unlike traditional centralized systems where data resides on a single server, blockchain distributes data across a network of nodes. This ensures data integrity by making it extremely difficult for any single entity to manipulate or compromise the data. Additionally, blockchain enhances transaction privacy by providing a transparent yet private ledger for financial activities. Blockchain serves as a comprehensive data storage solution encompassing a wide range of information including user authentication details, personal information, and transaction records. All financial transactions such as deposits, withdrawals, and fund transfers are securely recorded on the blockchain. Smart contracts, a key feature of blockchain technology, are used on the Ethereum platform to streamline various banking operations. These contracts contain predefined rules and conditions. In the context of this project, smart contracts facilitate account creation, deposits, secure transactions, and user-friendly banking operations. They ensure that these actions are executed efficiently and securely, eliminating the need for intermediaries and enhancing user experience. And the data integrity is maintained in the system through the utilization of the SHA-256 algorithm, that is secure hash algorithm 256-bit. Each block in a blockchain is linked with a unique hash code. These blocks are maintained across multiple nodes or servers. Before storing new records, blockchain verifies the hash code of each block. If any block data is modified, it results in a different hash code, triggering security alarms and ensuring the integrity and immutability of the data. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is hello8 folder. In this folder I have node modules folder. This folder contains dependencies or modules needed for the project. Now open .bin folder. This folder often contains executable scripts related to the project's dependencies. So here we can see a run blockchain.bat file. Double click on it to start the blockchain. This script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local Ethereum at this local host and port. So this address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. So I'm typing truffle space migrate and hit the enter button. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. So this is the contract address. This address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas consumed. Now minimize this. So this is blockchain bank folder. Open this. So this is bank folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is bank app folder. This folder comprises a static folder which contains files related to CSS, JavaScript, and Bootstrap. These files contribute to the visual and interactive aspects of the application. And bank app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is bank contract SQL file. This file consists of Solidity code. It handles data structures, functions, and events with modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating the database tables, applying migrations, and more. And this is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Now double click on it to start the Django application. So the Django framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Django framework, and here we can see login and sign up links. So if you are new users, we have to register first. Click on sign up here link, fill in all these details. The username is Naveen. Give the password, give the phone number, give the email ID, give the address, select the gender, and now click on register. So in the red color text we can see sign up process completed and record saved in blockchain. We will create another account, so username this time would be Raju. Give the password, give the phone number, give the email ID, give the address, select the gender, and now click on register. So the record have been saved to blockchain. Now we'll log in. Click on login here link. So we'll log in as Naveen first. Give the credentials, username and password of Naveen. And click on login. So we have logged in as Naveen, and here we can see deposit amount, send amount, view balance and logout links. Click on deposit amount link. So here we'll self deposit. So the username is Naveen, amount would be 1000. Now click on submit. So in the red color text we can see money added to user account Naveen. Now click on view balance link. So here we can see the current balance and we can see the details, username, amount, transaction date and transaction status. In transaction status we can see it is self deposit. Now click on send amount link. So here we can see a transfer amount screen. So the username is Naveen, available balance is 1000. So here we have to select the choose receiver name. So the receiver name would be Raju, amount would be 500. Now click on submit. So in the red color text we can see money sent to Raju. Now again click on view balance link. So here we can see the current balance, that is 500, and we can see the transaction status sent to Raju. And we can see the transaction date and time, the amount and the username. Now click on logout. Now we'll log in as Raju. Click on login here link. Give the credentials, username and password of Raju. And click on login. So we have logged in as Raju. Now click on view balance link. So here we can see the status, transaction status, that is received from Naveen. And we can see the current balance, that is 500. We can see the transaction date and time. Now click on logout. So similarly we can create as many user accounts as needed and easily send or receive money. So the conclusion here is, the project successfully demonstrated how blockchain technology can enhance the security of the financial sector by reducing vulnerabilities associated with centralized servers. Blockchain's unique cryptographic codes such as hashing algorithms ensure that once financial data is recorded, it can't be altered or tampered with. This unalterability guarantees the integrity of financial records, reducing the risk of fraud and disputes. By leveraging blockchain technology, the project enhanced transaction privacy. The decentralized nature of blockchain reduces the need for extensive infrastructure, and cryptographic measures enhance data security, lowering operational costs. This groundwork paves the way for future development and expansion, ensuring that the technology can accommodate growing user demands while maintaining security. And the project suggests that Blockchain's adaptability and advantages extend beyond this specific application. The technology has the potential to be widely adopted in various financial applications, ushering in a new era of security and efficiency in financial services across the industry.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.